12-lead delta motor can be configured for either 480 volts or 240 volts operation. The specific connections depend on whether you need the high voltage configuration or the low voltage configuration. For high voltage, which is 480 volts, you will connect the power supply leads to terminals 1, 2, and 3. Terminal 1 connects to tone, terminal 2 connects to T2, and terminal 3 connects to T3. This configuration is for operating the motor at 480 volts. For low voltage, which is 240 volts, the connections are more involved to properly configure the windings. Terminal 4 connects to T4, terminal 5 connects to T5, terminal 6 connects to 6, terminal 7 connects to 7, terminal 8 connects to T8, and terminal 9 connects to T9. Terminals 10, 11, and 12 are not used in the low voltage configuration. It is crucial to connect the low voltage leads in a specific order to maintain the correct phase sequence. Incorrect phasing can lead to the motor running backward or experiencing other performance issues. Always refer to the motor manufacturer's instructions for the precise wiring diagram. The motor should always be wired according to the manufacturer's instructions. These instructions provide the specific lead designations and connection diagrams that are applicable to your particular motor model. Following the manufacturer's instructions ensures that the motor is wired correctly and operates safely. Before energizing any motor, verify the motor lead connections with a multimeter. This step is essential to ensure that the wiring is correct and that there are no short circuits or other wiring errors. A multimeter can be used to check the continuity between the different leads and to verify that the resistance values are within the expected range. Firstly, ensure that you are working in a safe environment. To energize the circuit before starting any wiring work, use appropriate personal protective equipment such as safety glasses and gloves. Secondly, select the appropriate wire gauge and insulation for the voltage and current requirements of the motor. Using the correct wire size is essential for preventing overheating and potential fire hazards. The wire insulation should be rated for the voltage level being used. Thirdly, double-check all connections to ensure that they are tight and secure. Loose connections can cause arcing, which can damage the motor and create a fire hazard. Use appropriate tools such as wire strippers, crimpers, and screwdrivers to make the connections. The order and the way in which the leads are connected is of utmost importance. The manufacturer provides specific diagrams that show exactly which leads need to be connected together for each voltage configuration. These diagrams take into account the internal winding arrangement of the motor and ensure that the motor operates efficiently and safely. The wiring diagram will typically show the lead numbers and their corresponding terminals in the motor connection box. Follow the diagram closely and make sure that each lead is connected to the correct terminal. If there are any doubts, consult with a qualified electrician. When connecting the leads, it is important to use the correct type of connectors. These connectors provide a secure and reliable connection between the leads and the terminals. They also help to protect the connections from corrosion and other environmental factors. Make sure to use connectors that are rated for the voltage and current requirements of the motor. After making the connections, double-check to ensure that they are all tight and secure. Loose connections can cause arcing, which can damage the motor and create a fire hazard. Use a torque wrench to tighten the connections to the specified torque value. Before energizing the motor, it is important to perform a few tests to ensure that it is wired correctly. One test is to check the insulation resistance of the motor windings. This test can be performed using a megometer. The megometer applies a high voltage to the motor windings and measures the resistance between the windings and the motor frame. A low resistance reading indicates a potential insulation problem, which could lead to a short circuit. Another test is to check the phase rotation of the motor. This test can be performed using a phase rotation meter. The phase rotation meter indicates the sequence in which the three phases of the power supply are connected to the motor. Incorrect phase rotation can cause the motor to run backward. Always make sure to consult with a qualified electrician if you have any questions or concerns about wiring a motor. An electrician can provide valuable guidance and ensure that the motor is wired correctly and safely. Improper wiring can lead to serious problems, including motor damage, electrical shock, and fire. Make sure to follow all applicable electrical codes and regulations when wiring a motor. These codes and regulations are designed to ensure that electrical systems are installed and maintained safely. The National Electrical Code, or NEC, provides comprehensive guidelines for electrical installations. The specific requirements for motor wiring can be found in Article 430 of the NEC. This article covers a wide range of topics, including motor circuit protection, motor disconnecting means, and motor control circuits. Additionally, local electrical codes may have additional requirements that must be followed. These codes may vary depending on the jurisdiction. Using a multimeter is critical for verifying the motor lead connections before energizing the motor. A multimeter can be used to perform several tests that can help identify potential wiring errors. Firstly, you can use the multimeter to check the continuity between the different leads. Continuity testing confirms that the leads are connected correctly and that there are no open circuits. Secondly, you can use the multimeter to measure the resistance between the leads. Resistance measurements can help identify short circuits or other wiring problems. For example, if the resistance between two leads is very low, it could indicate a short circuit. Thirdly, you can use the multimeter to check the voltage at the motor terminals. Voltage measurements can help verify that the correct voltage is being supplied to the motor. If the voltage is too high or too low, it could indicate a problem with the power supply or the wiring. Before using a multimeter, make sure that you are familiar with its operation and safety precautions. Always disconnect the power supply before making any measurements. Use the appropriate test leads and probes. Wear safety glasses to protect your eyes. It is imperative to use the appropriate wire gauge for the voltage and current requirements of the motor. Wire gauge refers to the size of the wire, which is measured in American wire gauge, or AUG. The larger the AWG number, the smaller the wire diameter. The appropriate wire gauge depends on the amount of current that the wire will be carrying. If the wire is too small, it will overheat and could potentially cause a fire. The NEC provides tables that specify the allowable ampacities of different wire sizes. These tables take into account the type of wire, the insulation material, and the ambient temperature. To determine the appropriate wire gauge for a motor circuit, you need to know the motor's full load current, or FLA. The FLA is the amount of current that the motor draws when it is operating at its rated load. The FLA is typically listed in the motor nameplate. Once you know the FLA, you can use the NEC tables to determine the appropriate wire gauge. For example, if a motor has an FLA of 20 amps, you would need to use at least a 12 AWG copper wire with 75 degrees Celsius insulation. It is always a good idea to use a slightly larger wire gauge than is required by the NEC. This will provide a margin of safety and help to prevent overheating. It is equally important to use the appropriate insulation for the voltage and current requirements of the motor. Wire insulation is the material that surrounds the wire and prevents it from coming into contact with other conductive materials. The insulation must be able to withstand the voltage and current that the wire will be carrying. The NEC specifies the types of insulation that are permitted for different applications. For example, THHN insulation is commonly used for general-purpose wiring. THWN insulation is suitable for wet locations. XHHW insulation is suitable for high-temperature applications. The insulation must also be resistant to the environmental conditions in which the wire will be installed. For example, if the wire will be exposed to oil or chemicals, you need to use an insulation that is resistant to those substances. The NEC provides detailed information about the different types of insulation and their applications. It is important to consult the NEC to ensure that you are using the appropriate insulation for your motor circuit. If you are unsure about the appropriate wire gauge or insulation for your motor circuit, consult with a qualified electrician. An electrician can provide valuable guidance and ensure that your motor circuit is wired safely and correctly. Connecting the motor for the correct voltage is essential for its proper operation and longevity. Supplying the wrong voltage can lead to a number of problems. If the voltage is too low, the motor may not be able to start or operate at its rated speed. This can cause the motor to overheat and eventually fail. If the voltage is too high, the motor may run at an excessive speed, which can damage the motor windings and other components. Overvoltage can also cause the motor to draw excessive current, which can overload the circuit and trip the circuit breaker. To ensure that the motor is connected for the correct voltage, carefully follow the wiring diagram provided by the manufacturer. The wiring diagram will show you exactly which leads to connect for each voltage configuration. If you are unsure about how to connect the motor, consult with a qualified electrician. An electrician can help you determine the correct voltage configuration and ensure that the motor is wired safely and correctly. Proper grounding of the motor is also essential for safety. Grounding provides a path for fault current to flow back to the source, which helps to protect people from electric shock. The NEC requires that all motors be grounded. The grounding conductor should be sized according to the NEC tables. The grounding conductor should be connected to the motor frame and to the electrical service ground. Always make sure that the grounding connections are tight and secure. Loose grounding connections can create a shock hazard. Regular maintenance of the motor is important for ensuring its continued reliable operation. Regular maintenance tasks include lubricating the motor bearings, cleaning the motor windings, and inspecting the motor for signs of wear or damage. Lubricating the motor bearings helps to reduce friction and prevent overheating. The motor windings should be cleaned regularly to remove dirt and debris. Dirt and debris can insulate the windings and prevent them from dissipating heat effectively. The motor should also be inspected regularly for signs of wear or damage. This includes checking the bearings for wear, the windings for insulation damage, and the motor frame for cracks or corrosion. Any signs of wear or damage should be addressed promptly to prevent further problems. If you are not comfortable performing motor maintenance tasks yourself, consult with a qualified electrician or motor repair technician. An electrician or motor repair technician can provide valuable maintenance services and help to ensure that your motor is operating safely and efficiently. Correct motor wiring ensures optimal performance.